So hello everyone. My name is Tim Rechtenwald. I'm a master student at Saarland University in Germany and part of the research group of Giancarlo Pellegrino at CISPA. In the following, I want to present our paper, YuraScanner, leveraging LLMs for task-driven web app scanning. So, as you can tell from the paper's title, we will be looking at a novel web application scanner. And in general, these scanners are a popular choice for black box testing due to their automated nature. In the past, however, we've seen that more traditional approaches struggle with exploring the deeper states of web applications and have a rather shallow coverage. So, as an example, consider this common admin dashboard design. And on the left, you can see an unfolding menu structure, which requires 3 clicks to get to the management page of a specific entity. And then as a fourth step, you have to click on the Create button in the top right corner. This then reveals a new creation form with several input fields. And in this example, one of the input fields might be vulnerable to an XSS payload. Now, traditional scanners would struggle with uncovering this vulnerability since BFS or random crawling approaches are unlikely to perform all of these steps in the correct order. So essentially, the key limitation of these traditional scanners is that they lack any awareness of the multi-step workflows that are expected from users in today's web applications. More recent work actually tried to address this issue by proposing model-based methods. So for example, they applied reinforcement learning on user-provided traces. That being said, these approaches do not scale well, since user-provided traces or any other models cannot be easily transferred from one web application to another. Because of this limitation, we decided to not build our own model, but instead opted for large language models. Now, around the same time, actually non-academic approaches started playing with the idea of having these LLM-based agents, so browsing agents, to assist users with tasks on the web. So for instance, you would instruct such an agent with the task of booking a hotel in San Diego, and it would then try to navigate to a hotel website and fill the booking forms accordingly. However, this was a bit different to what we wanted to achieve. So instead of executing a single manually provided task of the user, we wanted to execute all kinds of different workflows in web applications. And for this purpose, we propose a fully automated and task-driven web application scanner, which we called YuraScanner. Now, since we want to execute various workflows in a web application, YuraScanner first has to extract possible tasks from the web application under test. And for this, it performs a shallow crawl at depth 1. And for each page, it extracts the text contents of interactable HTML elements. We then give these elements to the LLM and ask it to provide some appropriate tasks for the elements. So here you can see some real-world examples for tasks that are generated for an e-commerce application. So they were add a new category for products, edit the information for an existing product, and delete a previous order. Now you might notice that all of these tasks are imperative sentences consisting of an action word like add, edit, delete, and an object on which the action should be performed. As next step, we give these list of tasks to the task execution module, and this now executes every task in multiple steps. At each step of a task, we start by generating a textual page representation, and then given this page content and the current task, the LLM is supposed to issue the next command, for example, clicking a specific element, and we then execute this command on the page. And now by repeating these 3 steps, the LLM is able to navigate through the web application and hopefully execute the task successfully. While doing so, we collect all the attack surface we discover, which is in our case forms. These are given to the vulnerability scanning component, for which we use the existing XSS engine of the state-of-the-art scanner Black Widow. And it now visits every form collected during the task execution phase, and it injects a list of predefined XSA payloads to find out whether the input fields are vulnerable or the forms are vulnerable to an XSS attack. To evaluate the performance of YuraScanner, we selected a testbed of 20 popular and modern web applications, such as GitLab and also Joomla, and we divided this testbed into 2 sets. The first set consisted, in the first set, we manually labeled whether the generated tasks were valid, and if so, if they were executed successfully. But since this involved manually labeling like a few thousand of tasks, we actually had to restrict ourselves to a random subset of 10 web apps for this evaluation. In the second set, we looked at any vulnerabilities that were found by YuraScanner and its automated attack component. And since this only involved manual effort for a reasonable number of vulnerabilities, we could perform this for all 20 web apps. Let us start by looking at the task extraction performance. So across the 10 web applications, YuraScanner generated a total of 2,361 tasks, and our manual inspection showed that 77% of these tasks were valid, and the remaining tasks were invalid. And invalid means that the functionality demanded by the task was not actually present in the web application. So these tasks were mainly generated on pages which actually had insufficient context for the LLM to generate meaningful tasks. So for example, if there was a login page with only a login button, the LLM could not come up with like reasonable tasks. Since YuraScanner relies on a task-driven crawling approach, its coverage depends on the task success rate. That being said, we found that 37% of the task executions were successful. And one example for a successful task execution is the task of adding new customers to the database in OpenCart. So you can see that YuraScanner in the first step clicked on the customers menu entry and then proceeded to click on the submenu entry of the same name. Next, it clicked on the plus icon to add a new customer, and then filled and submitted a form with several input fields. Next up, we saw that 25% of tasks were partially successful. And now partial means that YuraScanner managed to find the target form of a task, but there was a failure at the last step. So for instance, it tried to submit a form, but there was a form validation error. However, we still consider this as a partial success since we discovered the attack surface was increased because we still found a form. Lastly, the remaining task executions failed due to various reasons. For example, if YuraScanner executed like the wrong action or just gave up immediately at the start of a task execution. The clicker doesn't work anymore. Still doesn't work? Okay. Okay. Yeah. Okay, now it works. Thanks. So actually, like sometimes we were a bit too successful with task execution, as the following example will show. So the task was to delete a user from the user management section. And as you can see in this table, since there was only one user, YuraScanner decided to click on the delete button. Are you sure you would like to delete this user? Yeah, sure, go ahead. User deleted successfully. Okay, great. We've executed the task successfully, so now let's move on to the next task. And for this, let's log back into the admin dashboard. Huh, wait. Why can't we log back in? Huh. Well, now to actually find out whether we've succeeded with finding a deeper attack surface with YuraScanner, we compared it with the state-of-the-art scanner Black Widow, as well as a BFS and random BFS crawler. So on the right side, you can see the cumulative ratio of forms discovered the deeper we go into the web application. And the blue area represents the forms that were discovered by YuraScanner and at least one of the other scanners. As you can see, this applies to 44% of forms, but at the same time, we see that the percentage stays almost identical after a depth of 3 steps. In contrast, the forms found exclusively by YuraScanner, which is the orange area, still increase after this point. So this means that essentially these 40.3% of forms found exclusively by YuraScanner have a depth greater than 3 and thus appear to be out of reach for existing tools. As far as the vulnerabilities are concerned, we found 13 unique zero-day XSS vulnerabilities in 3 out of the 20 web applications, and 12 of these vulnerabilities were actually found by YuraScanner. And the injection points of these vulnerabilities were located between 4 and 2 clicks away from the main page, with the vulnerabilities discovered by Black Widow being 2 clicks away. And let me quickly summarize my presentation here. So, for our paper, we implemented YuraScanner, which is a fully automated and task-driven web application scanner. And since it's fully automated, this means it also features an automated task extraction phase. In the evaluation, we saw that YuraScanner executed 61.3% of the tasks either completely or partially. And the unique attack surface, while executing the tasks, appears to be deeper compared to traditional scanners. So this means that task-driven crawling can be used to effectively complement traditional scanning techniques. Contrary to what's stated in the paper, we actually decided to open source the code of YuraScanner after careful consideration. So feel free to scan the QR code and check out the repository. And with that, I would like to wrap up this presentation. Thank you very much.
Back to the example of booking a hotel in San Diego. By the way, is that task successful?
This was only like an example for non-academic tools. Like there are different tools not by academia which propose like such agents, and there are some common examples like on GitHub pages, and this is like a common example. They show like book me hotel or like something around.
Thank you. So my question is, for these tasks requiring providing your sensitive information, because your agent is fully automated, how do you deal with those sensitive information? You just provide it first, or when it asks you, you input them?
Okay, so yeah, maybe there's a little misunderstanding here. So for our automated agent, we do not provide like any information beforehand. So we just ask the agent to fill forms with some, well, like information the LLM comes up with, since we mainly executed this on locally hosted applications. So you don't actually give like any sensitive information to the agent. Like, of course, you could modify this and to give like sensitive information to this, but yeah.
Then what task are you doing? Are focusing on? If there is no sensitive information.
Like YuraScanner basically looks at the web applications and looks at the elements which we see on the site. So for example, we executed it on e-commerce sites. So you see like there's like an orders menu, and you just and so the LLM comes up with a task with, yeah, like maybe a task could be to add a new order here.
Okay.
So basically the task is to exercise as much of the web application as possible. And if you add a new order, it's not really important like what the actual like information is. It's just important that this functionalities like exercise and new forms are found.
Thank you.
Hi. So if I understood correctly, the goal is to use this locally, or is this also being used like in the wild on websites?
Yeah, so in our experiments, we only used it locally. We also, like as part of my master thesis, I'm also looking into applying this on live websites. But in the current state, like what's in the repository, the countermeasures that we see on live websites, like captchas and so on, are sufficient to like prevent misuse of the tool in the current state. So yeah, like we tested it on locally hosted websites. You could, in theory, apply it to live websites, but there are some like limitations. Yeah.
Okay, could you then quickly comment on sort of how you would handle the ethical aspect of the tool suddenly causing actual harm to the website rather than just doing a evaluation of the website?
Yeah, like, of course, if you are like testing it on live websites, the LLM will take the action. So if the LLM tries to like do some malicious stuff, yeah, of course you would be responsible for that because you are the one like starting the tool. However, there are options like to disable also the attack component, and also we would not advise using this on live websites without the consent of the owner, since this is like trying to execute XSS payloads, which is of course illegal. So like, yeah, usually like as everything, caution should be applied here. Yeah.
Okay, thank you.
So going back to this live site question, so with offline you can validate the vulnerability by looking at the source code, correct?
Yeah.
On live, is there a plan or an idea of how you would validate that as a true positive XSS versus a false positive?
Like, yeah, since
Let's say you have permission from the owner to actually run this tool on their website to find bugs.
Yeah, like if you have permission, you can probably like ask to get access to the backend source code, or maybe like if you already done that step, so maybe.
Well, I guess my
easy.
question is more of do you have any idea how you would do it if you don't have source code? What type of validation you would have to do? You don't have to answer. I mean,
Yeah, like I don't
you
have
a
a really.
question?
It's like it's a separate question,
Okay.
I would say. So
All
it's a bit. Yeah.
Thank you.
Thank you very much.
Any more questions?
For the deleting example you mentioned in the slides, how do you exactly handle them? Like stop the model executing all the deleting tasks, or is there anything you want to do to prevent it from happening?
Yeah. So you mean like deleting its own user account?
Yeah.
Yeah. Yeah, so like right now we are looking into more directions with this tool, and also like looking more into the interdependencies of tasks. So this was only like handled, a bit. So we did not handle this explicitly with this tool, but you would have to add some new like countermeasures against like deleting itself and so on. So there's no like functionality for this in this version here.
I see. Because like you're saying you're detecting cross-site scripting vulnerabilities, right? I feel like the task of deleting operation is not really helpful for the injection, right?
Well, it depends. Like if a deletion for like if for deletion there's like some kind of confirmation form where that asks you to write out like maybe the value that's displayed. It's an input field, so it's a potential attack surface, and you could still like try to inject something in there. So yeah.
I see. Thanks.